troubleshooting. In this nugget, we're going to talk about troubleshooting problems in Linux. Instead of taking a couple scenarios and showing the solutions to those scenarios, I've chosen instead to show you commands and config files and tools that will make your task of troubleshooting easier. So pull up a chair, put on your favorite Sherlock Holmes hat, and let's get to work. I want to start out our discussion of troubleshooting by just talking about a few things that you can do that will make troubleshooting on your system a little bit easier. One of the things that I don't like about a lot of troubleshooting literature, troubleshooting books, is that they just offer a series of problems and a series of solutions, but if your problem deviates from the one that they specify in just a little way, then the solution doesn't seem to apply either. So what I'm trying to do in this nugget, at least initially here, is to talk about some general ideas of things that you can do that will aid your troubleshooting processes. Okay, so the very first thing I wrote here is to shell out $3 for a notebook. All right, people have no problem spending hundreds of dollars on a monitor or some fancy external disk drive or whatever, right? But they don't want to spend $3 on a notebook and keep track of what's going on their system on a day by day or week by week or a month by month basis. So this is really important because if you have all of this stuff kept in a notebook, first of all, your notebook is not prone to disk crashes, okay? And when your disk crashes, it doesn't affect your notebook. I guess your notebook could catch fire along with your whole office or something, but that's a more serious issue, and I guess I can't really address that. But in your notebook, the kinds of things that you should keep track of, first I wrote in here is system hardware. Especially if you're building a system from scratch, keep track of as much as you can about the system hardware. Keep track of manufacturers' specs on devices. Keep track of jumper settings that you made on your disk drives. Keep track of the kinds of cards you've installed. Keep track of IRQ settings for your hardware. Things like that. All that sort of stuff will aid you in the troubleshooting process one day potentially. Then keep track of the installation of your operating system. Keep track of what kinds of decisions you made during the installation. How did you partition the disk? How did you, what kinds of software packages did you install? Things like that. Okay, what kinds of drivers did you put on your system and so on. And then as your system lives and evolves, keep track of hardware and software additions or subtractions that you made from your system. Okay, and again, all of this stuff, anything that goes wrong during the process, like you tried to install this software but this library was missing, so you had this conflict and so on. Keep track of all of that stuff. A lot of times what I find is that the same problems creep up in slightly different forms, and knowing how you solved the problem in the past will help you solve a variation of that problem in the future. And going back through your logbook is one way to really save yourself a bunch of time and effort. Instead of recreating the problem from scratch, paging through a few pages of your notebook to see what happened in the past might save you hours of trying to recreate a solution now. Okay, and like I said, keep track of any anomalies that occur, any conflicts when you're adding hardware, anything that you think could help you in the future, keep track of, and some piece of that probably will help you in the future when you're troubleshooting. Now the next thing I want to talk about are kernel panics. So this is an area that you'll see a lot of messages on forums saying, I got a kernel panic, my system doesn't boot, what's going on, So what is a kernel panic first? Well, the name panic should clue you into something here. It's a problem that occurs that it's so serious that the kernel will stop the system. So basically, think about it like you're driving a car down the road and all of a sudden all these lights start flashing on your dashboard, your oil pressure, this, that. What do? Well, you don't just say, forget it. You don't put some duct tape over the lights and keep driving. You pull over and you stop your car and you evaluate what's going wrong. See if it's something serious or see if it's just some crazy, electrical failure that made some lights flash, right? So that's what the kernel does, is it stops the system in its tracks. When does this happen? Typically it happens during the boot process. And we can diagnose it by starting with the boot messages. So, this is another thing that you can keep in your logbook, is what do the messages say while your system is booting up, when it boots up successfully? Okay, and you can learn that what those boot messages are after the fact by typing the dmesg command, dmesg, and that will tell you what all the messages were when your system booted up. And you should have a copy of that around for, you know, in a case when your system boots successfully, so that when your system does not boot successfully, you can compare the boot messages of the unsuccessful boot to the boot messages of the last successful boot. And even if it's not the very last successful boot, even if it's a successful boot where everything's been kind of the same for a month and it's a month old, that's okay. That'll still help you diagnose the problems. And typically, again, typically I say because it's not always the case, but typically, you know, the few messages that come out in the boot messages before the kernel panic message comes out will help you diagnose where the problem is. You know, maybe it's mounting some file system and then you get this kernel panic, then at least you know, well, maybe it has to do with this file system, but if there were some successful things in the boot messages before that, like, you know, something was started or something else was mounted and those completed successfully, then you can sort of, you know, eliminate those from consideration in terms of where the problem is. And then another way that you can diagnose problems with regards to kernel panics is using the lkcd, which stands for the Linux Kernel Crash Dump Package. Okay, so you can install this from source or RPMs, and once you get it installed, then you have to provide a patch for the current kernel version that you're talking about. And then once you get all that set up, then install that as a new kernel. So we talked earlier in this series about creating a customized kernel. This is one example of something that you could add to your kernel to have a customized kernel on hand. All right. Now, what happens when there's a panic? Well, a panic results in the LKCD dumping the RAM out to disk. This is called a core dump. All right. So what it does is it dumps RAM out to disk, and there's a particular file. And it will do this even after the panic happens. So the kernel panic happens, and the kernel might not be completely functional. In fact, it's not going to be completely functional if there was a kernel panic. But there's enough functionality in the kernel that it can write memory out to disk. Okay, and so you'll have some sort of a like a fingerprint or a record of what was going on in the system when the kernel panicked. Once you've got the LKCD package all installed, it might be nice to test it out before you're forced to use it in a real kernel panic situation. So what you can do to test out, to create like a sort of a false kernel panic, just so you can test out the utility, is just write this little C program. Open up any text editor and type this in, you know, character for character. And then compile this program with the cc command. So you say cc -c -l user Linux include panic.c. And this file you should call panic.c. Okay, that will create an object file, panic.o, and if you do an insert mod with panic.o, then that will create a kernel panic on your system. All right, then once you've got a panic created, whether it's this test one or you had a real one, you can run the lcrash program. Now the lcrash program takes a few parameters. It takes a system map file, it takes a dump image, the core image that got dumped by the program, and then it takes a kern types. So a typical way to run it would be like lcrash/boot/system.map ./dump.1 or whatever your dump image is called, wherever that's located, /boot/kern types. We'll run the lcrash program. You'll get a prompt. You can type help at the prompt and see all the different kinds of things that you can do with lcrash. And one of the things that you're trying to do with kernel panics, right, is that you're just trying to diagnose what's going on in main memory, like what kinds of stuff is going on, what kinds of stuff was running, and things like that, and trying to narrow down whether this kernel panic resulted from a hardware failure or a software failure. That's kind of like the first step. So one of the things that you can look at that will help you diagnose that is you can take a look at what are called instruction pointers. So an instruction pointer is basically an address into RAM that says which instruction was being executed. All right, and if you're getting multiple kernel panics and you look at all those kernel panics and you examine the dumps, then and the instruction pointer is pointing to the exact same spot every time, then that might say that it's a software error. Maybe every time it's running this one particular line of code in this one piece of software that you're creating some problem for the kernel that it has to panic and shut down the system. Okay, so whereas if the instruction pointers are like all over the place, maybe that says like there's some sort of hardware glitch. And the other thing to do is apart from all these utilities that we're talking about, just practice good science when you're troubleshooting. Eliminate variables. Remove things from contention. If you think there's a problem with your main memory system, then pull out one of your memory modules and leave the other ones in and boot up and see if everything works fine. And if it does, then maybe that memory module that you pulled out was faulty and that was causing some problems. Maybe things were being loaded into that memory module and then being corrupted really quickly before programs could run, or something like that. Okay, so you've just got to practice good science, eliminate variables, and anything you haven't eliminated from consideration, you have to keep an open mind that could be one of the problems that is causing a kernel panic or whatever other kinds of problem you're having on your system. Now, another thing I want to do is poke around the proc file system with you. Now, the proc file system is located in /proc on your system. It's not really a file system. That's kind of an illusion, okay? What's really going on here is all sorts of critical information about the system is kept in various files and directories and subdirectories under /proc. Okay, so if we do a listing here, you can see there's all sorts of things in this proc directory. First are all these directories that have numbers associated with them. Okay, what these things are is they're actually for each process on the system. This is a process identification number, and if you go into one of those directories, like if you go into CD 4625, for instance, and we do a listing, we see all sorts of information about that particular process. So if we print out a command line, for instance, you'll see that was my Emacs process that's running, okay? And you can see down here I've got the Emacs process running. That's what I typed at the command line to execute that process. Then it has all sorts of other information about that process, memory usage, and so on, okay? So for every process on the system, each process identifier has a directory in the proc directory that's keeping information about that process. So this is one place that you can learn about particular processes. Don't forget about the top command and other commands to examine processes. If you see some process that is troublesome in some way, like you're suspicious about some particular process, well, you can learn all about that process in the proc directory. Now, the proc directory also has other stuff in it, like CPU info. So this is all about, what kind of your processor on your system, the central processing unit, information about its speed and capacity and things like that. Okay, information about file systems on the computer, information about the interrupts that are assigned, the I/O ports that are assigned. The K message is a file that controls or holds kernel messages. Load average keeps track of the load on your system, so it tells you in the last minute or 5 minutes, 10 minutes, what was going on your system. Mem info keeps track of all sorts of memory information, how much space there is, how much virtual space there is, how many pages are resonant in memory, things like that. Okay, so poking around in this file system is a good exercise in learning about your system. You're going to learn all sorts of things about your system by poking around in here, and it's a good place to come if you're troubleshooting a particular problem. Now, there are some built-in commands that look in the proc directory in a more sort of formatted way. Namely, one of those commands is called lsdev. Okay, so if we look at the output of lsdev, you'll see what I'm talking about. lsdev actually looks at 3 different files in the proc directory. It looks at proc DMA, proc interrupts, and proc I/O ports. And then that's how it populates each of these 3 columns, and it tries to consolidate data. So if there's information about some particular device in the DMA file and in the IRQ file, then it prints it out on the same line. And that's nicer than just having you go to the individual files and try to consolidate things. Now, that being said, sometimes it's not able to consolidate things because in one file, the device is named one thing, and in the other file it's named slightly different, and it doesn't know that they're the exact same device, and so it can't consolidate that information. So you're going to have to intervene sometimes to get all the information consolidated completely, but it does a pretty good job of it. And so it's just a nice way to look at this information, by cross-referencing a few different types of files. Another one of these commands is the lsmod command, and this command looks at the modules that are loaded on your system. You might have remembered this from when we looked at kernel modules. You can see here information about the different modules that are installed, and also what they're used by. Okay, so you can see some sort of module dependency with this information, and that might help you diagnose certain kinds of problems with regards to modules if you're having those on your system. Another one of these commands, or a pair of these commands, is like lspci. This allows you to look at all the PCI devices on your system. There's another command, lsusb, that allows you to look at USB devices. And like I said, all of this information is being pulled from the proc directory, and it's just formatted a little bit more nicely than the files are sort of in the raw format in the proc directory. Another command that is useful for diagnosing problems is the lsof command. This command lists all the open files on your system. Now, files is a pretty loose word as far as this command goes. We're talking about regular text files, we're talking about block devices, streams, network files, directories, all sorts of things fall into the category of file as far as this command goes. If we type the output of this command and pipe it through more, you'll see the kind of stuff that comes out. It talks about the command that initiates it, the process ID of that command, what user owns the command, what type it is, whether it's a directory, regular file, a FIFO file, what the name of the file is, and so on. Okay, so all of these things, I mean, you can see this just goes on for pages and pages and pages. Since we just talked about shell scripts in the last nugget, one nice thing to know about lsof is that you can give it a capital F option, and then it will print out the output, the same output that we just saw, but it will print it out in such a way that it will be very easy to parse by certain scripts, like a Perl script. Okay, so if you have some issue with open files on your system, some runaway process that you'd like to monitor, then you could write a Perl script that looks at lsof and monitors certain things. It could output this file and then search for certain regular expressions in here, like a particular process name or a particular port or something like that, and it could sort of automatically check for things so you don't have to manually do it. A lot of times problems on your system result from the setting of some particular environment, whether it's the setting of a particular environment variable or the setting of a kernel parameter. Those sorts of things can affect the running behavior of your system. So for the rest of this nugget, I just want to concentrate on all these different environments and the files and commands that control the different environments on your system. So one of the commands that you have at your disposal to look at kernel parameters is the sysctl command, system control command. This command, what it does is it actually looks and works with files in the proc sys directory. So in this directory, you'll see a bunch of subdirectories. Okay, let's just go into the kernel subdirectory, for instance. In the kernel subdirectory, you'll see a whole bunch of files. Okay, well, with the syscontrol command, sys, if I can spell it, there we go, sysctl, you have a few different flags that you can use with syscontrol. The -a option will display all of the settings for all of the kernel parameters on your system. If you want to change a particular kernel parameter at runtime, while the system is up and running, you can use syscontrol with a -w option. W will write a new value for a particular kernel parameter. Yeah, okay, so, and the way that you specify this kernel parameter is you specify it as basically the path from proc sys down to the particular file. So say I want to change the domain name on my system. Okay. Well, the way that I would specify that is I would say kernel dot domain name. Okay. And I would say equal, blah.com or something. Okay. Now this will change my domain name at runtime. All right, and you can see the sort of the format of this. Kernel.domain means that there's a file domain name in the kernel directory, which is a subdirectory of the sys, which is a subdirectory of proc. Okay, so that's how you can set things there. You can also load in a new configuration file for syscontrol with the -p option. Typically, the configuration file that is used is a file in the etc directory called syscontrol.conf, and there are some settings in there that get done every time the system boots up. If you want to modify some settings in here, you could call it syscontrol2.conf, and then run the syscontrol command with the -p option and just specify a separate configuration file like syscontrol2.conf to read in a separate set of settings to change other kernel parameters on your system. Another kind of environment problem that creeps up regularly with Linux is it has to do with shared libraries. There's a file in your etc directory called ld.so.conf, and this has to do with shared libraries on your system. So you can see here there's a whole bunch of directories here, and each of these directories contains libraries that you want shared across all the users in the Linux system. Okay. Now, so this creeps into play if there's some library that you've installed on your system, but people don't seem to have access to it. Well, the reason they might not have access to it is because you didn't add it to ld.so.conf, and maybe you did add it, and all it takes to add it is, opening up some text editor like VI or Emacs and adding a particular line. But even if you do add it to the text file here at ld.so.conf, you have to run ldconfig after you get done doing that. Once you run ldconfig, then it refreshes the cache, the ld.so.cache file, and that cache file keeps track of where all the shared libraries are on the system. Okay, so like I said, that's a common source of problems with Linux, and this configuration file is what takes care of making sure that's seen by everybody. It's kind of like adding a particular path, a particular directory to your path environment variable. You can't run commands that are in the /user/sbin directory by just typing the command at the command line if you haven't added /user/sbin to your path. And the same thing, you can't access shared libraries unless the directory that the shared library lives in is in this particular configuration file. And the last thing I want to talk about is, the user environment. So when a typical user is not able to do something on the system, or if one particular user is having a problem and all the rest of the users seem to be doing okay, then it's probably a user environment problem. And remember to check the user environment scripts and various things like the .bashrc file or the .bash profile, or on SUSE Linux that's called the .profile file that lives in the user's home directory. And remember that in the etc directory a lot of these things are done globally for all the users. So if you make a change to something in the etc directory and then all of a sudden everybody starts having problems, it's probably a change like that. Remember, there's files in here like login.defs. Okay, and this file controls all sorts of things for all of the users on the system. So the default path settings that are used when you log into the system are for every user is set to user local bin, user bin, and bin. And then there's a new different default path setting for the root user. So like sbin, bin, user sbin, and user bin. Okay, so these are the kinds of things that can be set in a global way that can affect all of the users on the system. Also, don't forget about there's a file in the etc directory called profile. Now, profile on a SUSE Linux system is not supposed to be modified. On some versions of Linux, it's okay to modify etc profile. Here, they say explicitly, if you want to make changes for the global system, then do that in etc profile.local, because if you do it here, it's just going to be lost. Okay, so that's another file in the etc directory that controls global environment settings for users. Similar to the etc profile and etc profile.local file is a file called in the etc directory again called bash.bashrc in SUSE Linux. In other versions of Linux, it might be called bash.conf or bashrc.conf, and there's all sorts of variations. That's one thing that varies quite a bit from one version of Linux to another. Similarly to the profile, etc profile file, you'll see that SUSE Linux does not want you to change bash.bashrc. These are settings for everyone on the system. They want you to leave this file alone, and if you want to change bash configuration settings for everybody on the system, then you should use etc bash.bashrc.local. And there, your favorite global aliases and other environment variable settings can be made, and they will be propagated to everyone on the system. Well, it's time to wrap up our nugget on troubleshooting in Linux. And the first thing that I tried to stress to you in this nugget is to keep thorough, organized records of your system. Keep track of changes you've made to your systems, the installation records, all sorts of hardware information that you can keep. Keep track of your boot messages and all that sort of stuff. And it's like backups in the sense that, all these thorough, organized records don't do you any good until you have to troubleshoot, but when you have to, they're priceless, okay? And just like backups, you can't stress enough ahead of time that the more effort you put in to a good backup plan or a good thorough organized records in a notebook, the more that you do that, the more it will pay off when you need it. We talked about the lkcd package that you can install in your system that will allow you to analyze core dumps and things like that. And then we talked about the proc directory, which is this very special directory in Linux that keeps track of all sorts of system information. We talked about some various commands that access the proc directory, like lsdev and lsmod and commands like that. And then we talked about files that live in the etc directory that are useful, files that control shared libraries on your system, and also global configuration settings for the user environment and the bash shell environment and things like that. Well, I hope you found this nugget informative, and thanks for watching.